Yeah, this this section may not make a lot of sense, but I would like you to just take something from it, just some understanding, and hopefully you can get back to these slides. And when you are doing your assignment, I think this will be very helpful. Um, kind of important lecture will give you a little bit easier time doing your assignment, I hope. You will not get into maybe weird rabbit holes where you don't understand what's happening. So yeah, let's get started. Um, okay, these are just like best practices that we hope that you do in your assignments. Not we don't hope, we want you to do it. Use Rust formatter. Uh, Rust formatter is just basically formats everyone in same kind of syntax style. There's a, I think, Rust formatter file, right, in our assignment. So yeah, it's a good thing, use it. A lot of these slides are actually from some cohorts where we had like a longer frameless assignment. And these are where the things that we saw a lot of people make mistakes. Or it's not a mistake, it's all right, but there's a more Rust way to do things. So if you look at what we are doing here, we get some optional, and then we do some matching, right? A bit nicer way to write it is just using some combinator function to have an error and just use a question mark. And this will just uh, prop up the error back to the caller, right? Yeah, no problem. I'll be moving fast because I feel like these are more nitpick issues, but stop me if you want to. Yeah, there are, we said that we should never panic in runtime, right? That is still valid, but there are times when you know that something cannot panic. Somewhere you, on the top, check that it is some, so you unwrap it, right? Uh, but this code is pretty simple, right? Imagine you have a like big, huge uh, file where maybe at some point, like 20 lines before you checked for something that, and you know that in uh, at some point that, yeah, it is for sure there is some value, right? But somebody will change someday something on the top and things fall apart. So it's good to leave some note for your future self, at least if you are doing this. You could do something like, instead of unwrap, do expect, put some note. Uh, this is the minimal, I think we should do it, but I'll also touch on a bit more defensive way of programming at the end of the slide. Okay, fun stuff now. You will see this pattern a lot in Substrate. You will have some type as some trait that it implements and its associated type. And you should be kind of familiar with this. You will see this more and more, and then probably you'll make a better sense of it, but just something to remember. So let's give an example. You have some trait config which has some type, and then what you want to use is some type C that implements the trait config and its associated type extrinsic. And here it's like a small thing, but if you look down, let's say you want to use so in this, the second type is also like a generic that implements another trait, header T, right? And header T has a type number. So imagine you have to use something like this all the time. C as state config, associated type header, whole thing as state header T, associated type number. So we will do this a lot of time in Substrate where we create this type alias, where we, yeah, very common syntax, create a type alias, use number for instead of trying to have this fully qualified syntax everywhere. Another thing is your runtime uses no STD environment, which means okay. Why do we use no STD? Because the Rust core STD library does a lot of things for which you need a OS access. Like you need a console access. You do some IO operations, and we cannot do that from Wasm because we need a deterministic execution, right? So we use no STD, but that does not mean that you don't have access to core STD libraries. So what we do is we have our own SP STD library where we re-export few things that you can use. So this is kind of important because in your palette file, you will see, actually, I probably have a slide. No? Okay. I think I have a slide later where I'll show you there is a line on top of, yeah.
Just wanted to add a quick thing. I think recently all the stuff that we needed has landed in core and alloc. And so I think SPSTD is being used less and less just as a, but it's still the same idea that we use core and alloc crate, right? And so we use things from the STD library, just not the IO stuff, as you were saying.
From the core and alloc library are the things that are re-exported in SPSTD, right?
Yeah, like vector, right, and option, and all the kinds of things.
Yeah. So yeah, basically core and alloc. So Rust kind of the Rust standard library divides it into multiple like components. There is STD, there is core, there is alloc, and most things that we need to use are from core and alloc, and our SPSTD re-exports them. Yeah. Another thing you will see in your cargo toml files. So in your palettes, you will have fetch some dependencies. And so cargo features is like a way to say conditional compilation of something. So imagine, what you're saying is your crate supports this additional feature. And when you compile with this feature, it will pull some other features from some other dependency. So in this case, what you're saying is, let's say you're doing a cargo compile with additional feature, you're gonna also depend on this feature from this dependency. So again, your palette, you will probably fetch a lot of dependency. You'll put dependencies here. You always put default features false because we, again, work in an OSTD environment. And you put another feature STD where you pull in other dependencies STD feature. Why we use STD also? So we could have just used no STD, right? But for test, we still use STD feature. Yeah.
While we're getting this fixed, does anyone have any questions regarding the weird syntaxes that are being used? Like Rust questions, features, feature propagation, associated types, traits?
Maybe you can elaborate a little bit about the debugging testing practices when it comes to palettes.
So one thing that can happen that's quite a common, I don't know how common it is recently, but it's definitely been common in my history of working with Substrate and Frame, is that you will try and compile something and it will complain about things, and the magical word that you will find is either STD is mentioned directly or parts of STD are mentioned, particular. This does a Rust standard library that they're like, oh, this is not available or something. And it usually indicates that something went wrong with exactly the feature propagation that Ankan was talking about with the STD flags. So one of the things I've had to do that I hope you will not have to do, but if you do, is that you need to go through the feature selection of your dependencies and see whether the STD features are propagated properly. And a tool that's super useful for this is called Cargo Tree, if I remember correctly. It allows you to kind of investigate the dependency tree of your crates. And I think it also has some stuff to investigate feature selection. Yeah, to debug this kind of thing.
So more questions? So this is the line you will see on all your palette lib files on the top. Don't remove it. If you remove it, you will get weird compilation errors, and this happened a lot actually last time. What basically it's saying is, so unless it's feature STD, don't use STD, use no STD. And if you remove it, you probably get some error like this, where you are probably pulling multiple dependencies from Rust library as well as our SPSTD library. Something, if you see this error again, maybe you remove this or try to do something where you're trying to execute some Rust STD thing in your Wasm, in your runtime code. So yeah, this was what I was talking about. So you do get access to most things that we can use in our runtime, and but just import this. You will get access to vec, collections, map, stuff like that.
Notably not hash map though. Why? I guess I just remember they were saying that it wasn't like supported by the substrate as well. Yeah, the question was, why is it not supported, right? It's because the hashing is not deterministic as far as I remember. Because when a blockchain context in the runtime, everything in the runtime needs to be deterministic.
I was wondering why is not deterministic. If you do the same salt, right, in every, it should be deterministic.
That would be my guess, is that there's some randomness in how they initialized the salts or something. I don't remember the details anymore.
But I would still think hash map is pretty bad because it's like a sparsely stored tree and it's not very efficient. And with blockchain, we work again. Yeah. Did the quality go bad? Right? Another thing you might notice that you will not be able to do printlns in your runtime. Why? Again, println comes from Rust standard library. It needs a console. But you can log. You can use the log crate that that our runtime supports. But one interesting thing is, I think I have slides. So whenever you print something in your Wasm, any string literals that you have in your Wasm, that inflates the Wasm size. So we still want you to not log anything in the Wasm. But when you're writing a test, you can log it. So I'll show you actually, I will show you this thing, yeah. So if you try to do some logging in your runtime, you will probably always see this output. Don't panic, it's all fine. We do this to optimize the Wasm blob size, but you can always write your code such that if it is STD feature, which is test, you could print something, right? And oh, shit. Sorry, 1 second. Yeah. So imagine you have some struct in your runtime which has fields and you want to debug print it, right? And this debug print will print all the struct names, right? That actually will really inflate your Wasm if you keep printing structs like this. So what you do something like this. You in your test in your std environment, you print something. Yeah, and you can do something like in your whatever code, you can say if it's std, print something. If it's not std, this block will never get executed.
And notably also not included in the binary, because the macro will make sure that the code isn't even included in the binary, so it's smaller.
So how do you print it? You cannot use println. What you can do is use this log crate. And log crate is pretty nice. You could do the other part that I showed you before, but this is very nice because then you can set some log levels. You can set some targets from which you can filter your logs. So this is very nice. And this is the standard practice that we use.
I think, although now I think we're using the tracing crate, but it's pretty much the same way. The same, it just has like some syntax improvements.
Say it again.
I think, but we're using the tracing crate now. Log also works, but you can use tracing.
But it's the same thing.
Yeah, it's
right?
the same thing.
So basically, this log will not really print. It kind of dispatches to another component, and unless you put this in your code, it will not really log it. So this is important to do it. And also, when you're running your command, your test, whatever, you should put in your parameters just log whatever foo is the target, log level. Similarly, so for every palette, you can have different targets, right? And then you can filter in logs the thing that you care about.
I look now at the cargo toml of the assignment, and I don't see the log crate. And we were explicitly said that we shouldn't use any crates that are not there. So I want to clarify on this point.
In the assignment?
Yes.
Yeah, you could add it. I will show you today in the substrate, at the Polkadot SDK, where we use this logic library. You could use similar.
Yeah, so it's not that you cannot add dependencies, it's that you shouldn't need to. But if you want to log, you can definitely add it. And if you want like to print the hex in a nice way, you can also import the hex crate. It's just like the reason why we tell you not to add dependencies is like you shouldn't need to. But I guess log was something that we didn't add. And also you can get stuck in like feature propagation hell. Because if you add a dependency, but you don't put default features false, and then everything might break and you start seeing terrible error messages, which is fine. We can help you if that's the case. If you really need to add a dependency, so if you want to add log, just make sure to put default features false just in case.
Okay. Another thing you cannot do in NoSTD environment is use floats in our runtime. Do you know why we can't do it? Any guesses?
For example, when we add 0.1 and 0.2, it's not 0.3, it's 0.300004.
Yeah, it depends on the programming language, the OS architecture. It can be non-deterministic calculation. And for blockchain, you need to have 100% determinism. Otherwise, you get chain splits, you get forks, right? Do you have any idea what you can use instead? Big numbers. Yeah, not too far away, but so we use something called per things. Per things is basically fixed point arithmetic. So to represent a decimal number, you just put it in a big number and have some resolution, right? So for example, okay, this was a just quickly example of all the things that can go wrong. I think this, some programming language, I think Python, if you do 0.2 plus 0.2 plus 0.2, it's not equal to 0.6. So you see these weird behaviors in float. So per things, what you can do is represent, let's say %, which has resolution of 1 as a number. So you can set 1 to 100, whatever, and then any number represents the %, but it has no decimal places, right? It has resolution of 1. And if you want higher resolution, there is something called per bill, which is parts per billion, right? So if you say 500 million, its value, so that's half, 50%. You get really nice like APIs to deal with these things. You can, you can look at the documentation yourself, but you can say from parts, something, from %, it automatically sets the values. And you get some cool things like you can directly multiply it with the value, and it kind of calculates the final value, right? Yeah. Similar to what I said. So basically, if the resolution is 2, 100 represents 1, 200 represents 2, 250 represents 2.5, 350 represents 3.5. Similarly, you can use whatever you want. So per million is per million part. That's the resolution. Like up to 6 decimal places. There is also a fixed U64 that you can use. Basically, this again stores the range from 0 to U64 max, and based on that, it calculates your percentage. Yeah, you can look over the SP arithmetic documentation and what you can use or not. Yeah.
The fixed U64, I was slightly confused. It's not from 0 to 1 based on the U64. It's the crucial difference to the per thing is that it can go higher than 1. The per bill is a fraction which goes from 0 to 1, and this one can go higher. And then how much higher depends on the size of the thing. Here it's U64, so it would be half of the bits. I think it's the fixed point is in the middle, so it would be half of the bits. So you have 32 bits, I think, for the for higher than 1. And I wanted to say that it says a small sentence there on a previous slide of like, oh, there are some precision concerns, but that's a story for another day. The whole math topic goes surprisingly deep. That's one of the things that we can talk about in later like office hours and stuff. If you run into trouble or if you're very curious, I've spent a good while dealing with the fixed point math at some point. Yeah, it's a topic up for questions, and it goes surprisingly deep. So,
I think there's a question.
where?
I'm just like curious to know, like, if we have kind of rounding when we are doing any mathematical operation over two values, similar to the problem we have in Ethereum when we are dealing with decimals and we're trying like to do kind of any math operation, and we have this. So we have it. It is kind of like safely handled here, or we still have the problem with the library.
So with fixed point, I didn't get, sorry, everything, but what you're asking is with fixed point arithmetic, is there a problem we can get into non-deterministic behavior?
I mean, like when we are doing like let's assume we have like total two numbers,
Yeah.
and we have decimals in the two numbers. Are we when we are doing kind of like any mathematical operation, multiply or division? Do we have any rounding things here? Because we have it in Ethereum in Fidelity.
So the rounding is not float. There might be rounding ceiling floor, but once it's stored, so you might do 5 by 2, right? That's like 2. It will store. So the value that you store in these fixed U64 or per things is actual number, the fixed number. You never store a decimal, right? And you do this kind of same thing that that your OS does, your programming language implementation will do, but we do it here with high resolution. No.
Like in Solidity, we don't have decimals. We don't store them. Like we just like represent the decimals by like a variable, and we kind of like this library for me is like a wrapper, like make it easier to handle decimals.
Yeah.
So like still with these kind of wrappers, we have the floating things. So we have the rounding things when we are trying like to do division, and then we want to kind of like round it. So we have the problem here or not?
Yes, like it's fixed point math. It's the same math that's everywhere in programming. As soon as you do fixed point math, you get, or like as soon as you do these kinds of things, you get rounding problems, and that's part of what the rabbit hole goes into. Yes, there's just like a surprising like how you deal with rounding depends on your use case. Like it's not that the same rounding is always safe. Which rounding is the right rounding to choose depends on the use case that you have and how you order the operations and so on and so forth.
So when you're writing your runtime logic, you will do a lot of arithmetic operation, right? There are other things that also could fail. You try to do addition to U32 max plus 1 with U32, right? That overflows. You do division by 0, that panics in the debug, but in release it just over. What does it do in the? Yeah, it will panic. If you divide by 0, it will panic. So what do you do? Okay, these are just examples. So what do you do? How do you handle those things? There are two ways. One is a bit better. The other is also reasonable. Depends on your use case. You always do some checked multiplication, checked division. What this checked API does is it gives you, if it succeeds, it gives you some value that you got, right? If it fails, it returns none, right? And the second option is using saturating. So if you do U32 max plus 1 here, it will saturate. It will never increase. Yeah. The saturation?
It's just like he can repeat it because
Yeah,
I feel like I'm.
So whenever you're doing multiplication, division, even addition, subtraction, it's best practice to use safe maths. What is safe math? Using, not doing directly plus minus. Use these APIs, checked mul, there's checked div. You do check add, checked sub, yeah, checked sub. And what it does is, if it succeeds, your operation succeeds, it doesn't overflow, it doesn't try to divide by 0, something like that, then it returns sum of your result. If it, for whatever reason, fails, it returns none. Okay? And the second way to do it is, instead of doing a check mul, because this returns option, and it's like you have to unwrap it, do something with it, right? Sometimes it's reasonable to just do saturating mul, which basically, if it overflows, it stays with the max value of that size, right? So where should you use saturating? Any guesses? Yeah.
Hello, Martin here. We can do saturation when we're calculating something from the beginning. For example, it could be a weight or gas, or like we start at 0, for example, and we just go and go and go. We're not adding to the state. We just starts from default, from basic, and then we can saturate.
Yeah. So to rephrase, I mean, there are situations where you think you can't do anything better. It won't make it worse. You just do saturating add. Like an example is, let's say dot balance. Yeah, number of accounts that we have, or yeah, balance. Let's say Yeah, I can't think of a great example right now. But in most cases where you think, yeah, it will take like years before you actually hit this error, you can just use saturating ad. You can reasonably assume that you will never overflow. Another type of error is if you try to cast a number that cannot fit in whatever integer size you are putting into. So if you try to convert 1000 in U8, what will happen is it will truncate the value. Do you have a question?
Yeah, like in the previous slide, I just want to make sure I get it correctly. I got like the explanation here, but my question is Rust by default prevent overflow and underflow? No.
So
It's up to the developer to hold the
it is
way.
so in debug build it panics, but in production build it overflows silently. So it's important that you use safe maths. Okay, so this will also return an unsafe result, right? So how do you do that? Rust has some nice states that they have blanket implementation. So all these are already implemented and you can use it. So imagine you want to convert from U16 to U32. What do you think? Is this okay? So you're converting to a higher size number and that's totally fine. But imagine you want to convert U32 into U16. Then you use the straight try from, and that kind of returns a result. If it can fit it, it returns okay, otherwise error, right? So another thing that you will see a lot in your runtime code and substrate palettes is you depend on a generic number. You don't know what number it is. So let's say balance. Almost every palette will use balance in some ways, but you don't depend on balance directly. It comes from your runtime. So what you're saying here, the first line is foo depends on t, where t is any number that can be converted from U32. What does that mean? What numbers can be converted from U32?
All numbers higher than U32.
Exactly. And the other way is true with when you're trying to convert into U32. Any number that is lower than U32 can be converted into U32. When you do try into, you can use any type and it can try to convert it if it can. Okay. Frame stuff. There are a few things that we do in frame that might seem odd to you or may not make sense to you very quickly or intuitively. But there's this get rate we use everywhere. So imagine you want to, the runtime wants to set some constants. How do you do it? So let's see. Thing is, when you start looking at the runtimes, you will see this parameter types a lot. What it does, it generates a get rate where the get returns just some value. I'm finding a bit hard to explain this because you have not seen this code, but what basically you are doing is your palette, if I do have slide, no. So your palette, in the palette config, you will depend on something which is get U32, and you set it from runtime. And so this is like runtime code where you will say, you create this parameter type which generates, so this parameter type is it's a macro, it will generate this struct foo, which implements this get u32, and you pass this to your palette. So this is a way where you can have compile time dependencies injected from the runtime to the palette. If it doesn't make sense, hopefully when we see the actual Rust, the runtime and the palette code, it will probably make more sense. But if you see this, you try to remember that what it's doing. Okay. Yeah, one example of where we use get u32. So I think we talked about this, that we want to have our parameters, our storage items bounded, right? Why do we need it bounded? Because again, blockchains are constrained environment. We want to have some limit to how much proof size we want to support per block. So this is like a no overhead thing where bounded vec is like a wrapper on top of vec, which also has this type that implements get trait. And dynamic on the run, like on the code side, it's not saved in the state. It's not saved in the storage. The implementation of bounded vec checks while you're trying to insert or do something with your vec that it does not exceed this size. Now, with this get u32, what happens now is the limit can come from config, some trait that you compile time injected into your palette, and you can use that as a reference. Again, it will get more clearer when you see examples. But just for the argument here, like if you try to do this in a different way, instead of having a get trait, imagine you just have a field u32 here, right, in your bounded vec. Now your bounded vec everywhere, you will have to specify whenever you're creating bounded vec, what will be the size of it. And it will be inside the palette. You cannot inject it from the runtime. The other things that you will see is your palettes depending on a lot of traits like convert. So I guess I have an example. Makes more sense. So imagine your palette needs some way to convert U64 into U32. So what you will do is you will just depend on a trait that is provided to you through the config and use this in your code everywhere. So in this case, our code, our trait config has stated type converter that is coming from outside this implementation. And then what you're doing is runtime, which is the struct, as state config, get from that the converter, the associated type, and convert it. So you're not writing the converter logic in your palette. You're again depending on some outside trait implementation. Yeah, inside your palette, you will do something like this. You will have functions that generic over T, which is like coming from runtime config, and you then from T as the trait config, get converter and do something. Cool. Another thing that you might guess, in your runtime, you have a lot of palettes, right? And for all the palettes, we need to call this on initialize. And you will have cases where you have multiple structs which all implement some trait, and you want to call something on it. So what you will do, you will probably do something like this. On initialize, get all the call one by one on all the types. Sorry, this was not. What you can do better is Rust allows this kind of syntax where you create a tuple of all these types. All of these types implement trait on initialize, and you call on initialize on it. This will do the exact same thing.
So is anyone understanding this? Like why we do this weird thing? Because I think that's a key point of understanding like why all this code looks like Rust kinda, but also it kinda doesn't. Is this like, are you all comfortable with your Rust? Is this okay? Because this is one of the things that like is not blockchain specific, or it's not even frame kind of specific. It's just Rust, but we use it in a way where we use types all over the place instead of values. So just if this doesn't click to you yet, or why we do this, then just look at it more and ask us. Let me go there.
Would it mean non-Rust to like put all these 3 types of uninitialized in an array and call uninitialized on all of them?
Which is what it is doing, right?
Yeah, so that's why, like in regular Rust or in any other language, if you were just a sane human being, you would use an array or a vector or a linked list, whatever. Here we use tuples because tuples are types, and we don't want dynamic dispatch. Like for example, here module 1, module 2, or module 3 might be completely different structs, but they all implement the same trait. So if you wanted to put them in an array, you would need to have a dynamic types, like types that implement an interface, but they're all different. That results in dynamic dispatch, which means that the programming language has to have like a V table, and every time you want to call a method on something, you need to check. It's kind of like inheritance. You need to check if, like, what actual implementation you need to call it from, and that takes time in the runtime. That makes it slower. So all of this we do so that at compile time, because these are types, so tuples are kind of like the type version of arrays. So because tuples are types, you can, like, at compile time, know what you need to call, and you incur no cost on the runtime. So that's the reason why we're doing all of this. So that's the reason why we do this. That's the reason why we do the get trait, which might seem very weird, or at least it seemed very weird to me when I learned it. So yeah, that's why we use types and tuples instead of arrays.
So one big point here is that in order to do this, you need to kind of implement this thing for all combinations of the tuple. So if you want to do A, comma B as in on initialize, this will not work because that combination is not implemented. So frame kind of provides this attribute macro where you can, on a trait, put this, and everything that implements, it will generate all possible combinations of this trait. So basically, you're generating all combinations of tuple, which can call this on timestamp set. Okay, this is kind of pretty important. Whenever you make some weird syntax error, something with the macros, you will get bunch of errors, and you'll be like, "What the hell did I do?" But most times, so in this case, in this case, what we did is put this index thing wrong, and it generated a lot of errors. And you panic, like, "What did I do?" Right? Generally, what happens is when one macro fails, then cascadingly a lot of errors are generated. What you can do, good tip, almost always this will work. You go to the first error in your like console, right? And try to see that error, and that will probably fix it. I think this almost works all the time.
Yeah, and there's a crate called or cargo ograk, which is cargo like upside down. That if you can install it with like cargo install ograk, and when you do like ograk test, it will run the tests, but then show you the output the other way around so that you see the error first. Sometimes it's useful when you have like a bazillion errors and you need to scroll for hours. It just like puts it there.
Yeah, so one other thing is sometimes the errors are so big that your console runs out of text, right? So it buffers out. You should probably increase this buffer size so you don't lose the first error.
So she just wants me to write it on Discord. I'll send on Discord the crate in case you want to use it.
Okay. This is the last topic. Yeah, I'll just let you read this. So while writing blockchain code, we try to be more defensive because it needs to be very secure. Small bugs can do very bad things. So a few examples that I guess we would expect it in your assignment as well. Let's say in your code, you kind of believe that this maybe value is never going to be none, right? So you unwrap. This is again a simpler example, but I mean your inference could be not very clear when somebody looks at the code. But you can be very confident and say, yeah, I know this shit. It can never panic. A little better thing at least to do, even if you're very sure that something will not panic, at least put expect, where you put some note on why you believe that, some evidence of why you think this will never panic. Like I checked some above and so it will not panic, right? A better way, because the code can get very complicated, right? And you might think today it doesn't happen, but tomorrow somebody changes some part of the code and something triggers some other behavior that you don't expect, right? So it's even better if you are defensive, which means you do something like this. Maybe a value, wrap it into some error, do question mark, which means basically it will propagate the error if it happens ever. So this I would say is the best practice. This could be fine in cases, but this is still like, it should be the preferred way.
I'm not too familiar with Rust, but when we do errors, do we want to create like error types?
Sorry, say it again.
Like when we return an error, is it the better practice to create types for each error?
I mean, depends. So we will see this actually. We didn't see this properly, but your error has some documentation to it, and when we use the metadata, we actually the UI has this metadata, like what the error means, which means you want to give some informative errors, as informative as possible. So it could be like, I don't know, you don't have enough balance, so you can repeat that error across multiple calls. But you think if the error is like new or unique, then you create a new type. So it depends.
Hey, Rodrigo here. This is also related with error handling, because I mean, I've been using OnGrab a lot of times, so I I'm kind of on aggressive programming sometimes. So I wanted to know who should be the responsible to handle the error, because I think the way, if you use expect or unwrap, the function responsible to handle the error would be in a lower level or in a higher level. I don't know if this makes sense.
I mean, so
Like which would be the best way to early grab the error? I don't know if this makes sense.
I mean, if you do unwrap, if that was your question, if you do unwrap, that panics. That's not error.
Right.
You should never do unwrap, right? Unless you can do expect, where you really believe something cannot be cannot panic. So you say something, some evidence on why you think this will not panic. About the errors, I mean, it depends. So you write your call logic, you get some error, you create your own error, you propagate it. There are some errors in the pre-dispatch phase as well. So, I mean, you look at code, you will see how we handle errors. But yeah,
And I mean, I was wondering if let's say the function A calls function B and C, and one of these two functions propagates an error, is, I mean, as long as the function A grabs them or catch them within a result or error, would be enough, to
yeah. So
handle it or not?
this is your pure Rust code. In the palette, whatever you write, you can inner function could return whatever. The final thing is at your call function level, you return some error, right? And a good error. How you do it, how you structure your code, it's your decision.
Like it's your decision whether to kind of swallow the error, choose a default value, and then just log something, right? Like, hey, I think it's actually shown there. It's like logging like, hey, this should never happen, but you have some way in your local environment where you're coding, oh, I can keep going with a default value, then sure, do that. If you cannot, then you need to design the function in a way that you can bubble it up. And
Yeah, so in Rust, there are basically two ways of handling errors. You either panic or you return an error. And panics are usually for unrecoverable errors, so there's no possible way that you can recover. It's basically like a coding issue, like someone programmed it wrong, there's a bug, so you should just panic. Like, there's no way the caller of that function can catch the error and fix it. When it's something where it can be fixed, you usually return an error, so that's a recoverable error. And there's a very good section on the Rust book, which I would recommend everyone here to read, but I'm gonna send it to Discord. The thing here with Frame is that we have this thing where you cannot panic. So basically all errors need to be handled via errors. The expect is kind of like if it's something very simple, like you really know that it cannot panic, like it cannot reach the state where it will panic, you put an expect and you put a little like proof of why it cannot panic, and hopefully for everyone reviewing your code, they can look at it and be like, yeah, sure, okay, this will never panic, because sometimes we know more than the compiler, but usually you would just return errors, like whenever possible. So you can do stuff like unwrap or default, or just propagate the error, and yeah, worst case, you just fail the extrinsic, but you don't panic. Of course, in tests, you can panic, and it's such a breath of fresh air when you're in tests, you don't care, and you just do unwrap all the time. So please do that, but never put an unwrap in a call.
quick meta note, I hear people's phones like making noises. It would be great if you could turn those off. I would really appreciate it.
So we said we want to be defensive. We think some code path will almost never happen. And if it happens, it's like something that you didn't expect it to. You create some kind, you emit some kind of defensive error, right? And what you really want to do is in your test, you should panic, and log something. Sorry, in your test, you panic, and in your like production, you'd log something, some error. Right? This is the behavior you'd like to have. So we do have these defensive traits, which does exactly same. So what it will do, when you say defensive OKR and some error, what it will do is if it's test, it will panic. If it's production, it will log some error. So use this if you ever have some logic that you think is good for this. Right. There are other ways for panic to happen as well. We already saw the division by 0. It can also happen if you try to set something in vec in an index that does not exist. What else? Any guesses? What other places where we can have panics? Yeah.
Call in directly, but of course we shouldn't.
Sorry?
Call in it directly, but I guess we shouldn't.
Yeah. If you leave a to-do or panic thing, it panics. Sorry?
From a dependency, you mean? Ah, yeah, from a dependency that we call.
Yep. So yeah, just remember or understand what things can panic. Understand the APIs that you're using. So vector, yeah, you do insert something in the index, it's not there, out of bounds error, or you try to remove something that doesn't exist. All these things can panic, depends on the library that you're using. Read the documentation carefully. Make sure you never panic in runtime. Yeah. So I'm not sure what this is trying to say.
I think this is just showing the pattern of documenting panics, right? It's like
Yeah.
if you provide a function that could panic, you know it could first avoid it, but if you really have to have one, document it.
So when you put like this 3 slashes, this is Rust documentation. And for all your public function, at least, you should document it nicely. And this basically, you already saw the frameless runtime template, right? You do cargo doc and it puts a really nice documentation of your functions. This is how you generate that. I'll leave it for you. Yeah, so don't do this. This is a really bad documentation. Cool. This is all for this lecture. We can take a 5-minute break unless you guys have questions. Any questions? No? So this presentation is trying to go more about how Frame manages storage. You already saw a few things like SPIO primitives and stuff, right? And now we will go deeper on how Frame utilizes those things to make life easy for you. Have you, until now, saw this storage overlay or Patricia Merkle tree? Like, do you guys understand what it is? I'll recap a little bit. So what you know until now, what you think it is like a key value database that like, we set a key and some value, right? But above this layer, there is something called a tri backend, which is basically a Patricia Merkle tree. So what we do, we create a Merkle tree and navigate that path and set some values in key value database. It's not exactly just some key and some value. There's a bit more nuance to it, or bit more complex than just key value database. Why we need Merkle tree? So we have storage proofs. We want properties where your the light client could ensure that, say, your balance is what you say it is just by knowing the storage root of the Merkle tree and some proof, some set of nodes, few nodes, not your whole state, to verify that the balance is right. Similarly, any other data, right? If all this doesn't make sense, please raise your hands up, because these are important concepts, and I'm expecting that you have already gone through all this. So yeah, I'm gonna try to be fast, but I would like you to, yeah.
So let's just ask the question. Can you raise your hand if you don't know what a Patricia Merkle tree is?
Good.
Cool.
Now, above your Patricia Merkle tree is also storage overlays. We'll go deeper, but I just want to give you an overview. Storage overlays are like when you start applying your extrinsics, you don't directly apply to your database. You have an overlay where you do some things, you cache the things that you have accessing, you're writing to, and only at the end of block you push it to the database. So what happens? What? Some runtime logic initiates the call. It calls the runtime storage API. First, we query this overlay change set. We try to see if the value is there. So I'm trying to check balance of LS. I try to see an overlay change set. If it's not there, then we go and see the database. We try to read this. We send it back, and then we cache it in the overlay change set. Another thing to remember is database calls are expensive. And as I said, maybe given a hint that one storage is not really one storage, it's multiple hops of storage keys that you have to get to the balance of LS, which means we want to do less database calls. Okay, so we check LS balance, we check Bob's balance, we cached it in the overlay change set. Now we transferred some balance. So Alice had 10, Alice transferred 5 tokens to Bob. What will happen? We only change the values in the overlay change set. We don't do anything in the database right now. And at the end of the block, all these state changes are committed to the database. And once it's committed, we calculate the state root, we put it in the block. All good? Important thing to remember, if you let's say read LS balance twice, the first time it reads from the database, but the second time it just gets from the overlay change set. And you think that's cheap? Yes, it is cheaper than database, but it's not totally cheap. It still is going via host API. It's still doing serialize and deserialize, so it has some cost. But this is not all. We can have more transaction layers on top of the overlay chain set. As we will see also later, we spawn a transaction layer for every single call automatically. But you as a developer also has a primitive to go and spawn your own transactional layer. So you are doing some logic, and you create this atomic set of block where you do something, and if something fails, you just discard it. Repeat, there is some overhead even with the overlay. That's like it's like 0.15% of what it will take with reading the database. Interesting thing is we don't keep copying around values in every storage layer. We just move pointers. So new balance ls somewhere is 15, and we just move the pointer of next overlay chain set to new ls balance and then to the database. In your call, we already talked about this. If you say okay, if you return okay, changes are committed. If you say error, automatically it reverts back any changes you did. But it doesn't really revert. It was in a transactional storage layer anyway, so it just discards it, right? Yes.
Does the way you were talking about the kind of buffer between the actual database and I guess just like the current execution, does that have anything to do with the extrinsic key that we were clearing out?
No. Extrinsic key is just set of extrinsics that we executed in the block. And we also want to have a root of that in the block just to have some integrity that these intrinsics were executed. But that does not have to do with the storage layer. The storage layer is more in the extrinsic. You did some state transition. You did some storage changes. And those are in the storage overlay set. But let's think. There is something here. So I'm not exactly sure of this behavior, but even at pre-dispatch phase where we set extrinsic key to clear, it probably does it in the transactional layer as well. So the whole thing is also in a transactional layer. I should not call it transactional layer. That's the storage overlay chain set, and then there are transactional layer on top of it. What is the point? I mean, intuitively, I think it's just probably for some security reason. I can't really exactly think what could go wrong. I don't know. Do you have any thoughts? Or
The extrinsics for a block?
yeah. So what we do in our blocks, we store we create like a trie of extrinsics that we're executing in the block, and we keep a root of it in the block. So intuitively, I think it's some kind of security feature. We can derive that, okay, these are the extrinsics that were executed in the block.
Yeah, I think that's the
But
idea,
do we,
right?
yeah.
I'm not sure it's crucial that they have to be in the storage, but you want a Merkle proof of the extrinsics that were part of your block.
What kind of attacks that can happen if you don't have the, yeah.
It's nothing with attacks. It's just for light clients, no? Because you want to have the Merkle root of all the extrinsics in a block, and then for people to be able to prove to people, to light clients, that a particular extrinsic happened in a particular block.
Yeah, I mean, I'm sure it's something related to that, but I can't really point out the exact attack vector. What we need is the state root for sure. After this block, the state root is this. That is like, I guess, very intuitive. This is what we need.
Yeah.
I'm pretty sure the extrinsic root also has some feature. I'm not exactly sure.
Yeah, I think you want to be able to prove that you send a particular transaction, particular extrinsic, at a particular block, and that it was included.
Yeah. If you want to prove that this extrinsic was part of this block, then you have to have that. Yeah, this is the same behavior in Ethereum. Smart contracts. I'm guessing more. Yeah. Sorry.
Maybe this is a stupid question, but if we actually wanted to prove an extrinsic was part of the block, wouldn't we have to store the Merkle tree somewhere?
I mean, you need to provide all the extrinsics in that block, and you can prove that that extrinsic was part of the block. You don't need to. So why do we need Merkle proof? We need to prove that some state is like your balance is this value, right? But for extrinsics, yeah, there's no Merkle proof, so you cannot do but just by maybe one extrinsic. Or can you? Yes, you can. Yes. So you have extrinsic root, right? Which is it's created by a Merkle tree itself. If you look at the frameless code again, we create like a Merkle tree of extrinsics and create a state root from it. So all you need to prove that your extrinsic is part of that block is that extrinsic and the root, right?
And like yeah, not the leaves, but like in the header, you only put the root, and in the body, you put all the extrinsics. So if you're a full node, I'm just talking from the light node perspective, but if you are a full node, you have the body, you know everything. But if I'm a light node, I only know the header. So I know what the root is supposed to be. So I ask you, like, hey, is this extrinsic part of this block? And you say yes, but you provide to me all the leaves, and I can, because I have the root, I can do the Merkle, like you give me the Merkle proof and I can prove it. So that's why. And like the tree, you don't need to store the tree to prove it. If you have the tree already, you know it. You just, someone has the tree and you have the root of the tree.
Happy? Okay. I mean, we can look more outside this lecture and
Yeah, it's the exact same as with the Merkleized storage. It's like you want to be able to prove that something is part of it, and you just have a parallel thing for the extrinsics. Like you have the same idea, and it's just like we separate the two because they're sort of separate concerns or like separate. Yeah. Right. Yeah. If no one has the history of your blockchain, you know, of course, right. Someone needs to have the history.
okay, I said we can spawn transaction layer. We could technically spawn as many transaction layer we want, but we put a limit on it. We put like 256, which is, I think, already pretty high. I don't know why we will have 256 transaction layers on top of each other. But imagine you're doing a call and you're having a transaction layer inside it, another transaction layer. You can nest it up to 256 values. Why we do that? Because the way the transaction layer works, it's on top of each other. And once you flush it, once everything is done, finished, the block is finished, from the top, it goes to the second, to the third layer, to fourth, finally to the database. So you can imagine there's an attack here where somebody just creates, if there is a user code path where you can somehow trigger multiple these nested transactional layers, you can create a lot of these transactional layers, and at the top only do some change. And that will have very high computation because we are copying a lot of things from one layer to another, to another, to another. So this is why we limit it, but I think 256 is a pretty high number anyways. Yeah.
I'm just wondering how you can limit, because like the smart contract should allow user like to do whatever like number of internal
I can't hear
transactions.
you, sorry.
Here's good? Okay.
Yeah.
I'm wondering how you can limit, like when we have a smart contract that allow users to do unlimited, like in theory, like
Okay.
as many as they want,
Okay.
internal calls, and like,
So this
I'm
is
just
not
confused here.
this is not on the smart contract level. This is runtime code. The only thing I could guess is you have some call that does create some transactional layer, and you will see more in our when I show you the palettes. You have some ways to redispatch calls to other calls, and you can somehow create this kind of loop where you're just creating more and more of the calls, and so it's like a user attack vector. Not like it's not the intention of the dev, but there's a flaw where somebody can trigger a lot of these calls and do something that basically does more computation than you're charging for it. So it's like a DOS attack.
It's like don't have a dispatchable function that has kind of arbitrary logic that enable user to revisit the function.
Something
again
like
or-
that. Yes.
Okay, gotcha.
That's my guess. I mean, we can look more and read more, but this is something kind of off topic. Anyways, okay, so let's move ahead. So what is the Patricia tree? Just to give a recap, let's say you have these keys in the database. You start with your state root, here it's P, and you start traversing the path depending on the children. So this is like base 2 Patricia tree. And it has 2 kids, ROAR, and to get like parity, you go to the right, then you to the left child, and the right child. Yes, you get it. This picture is clear for everyone, right? Important difference: Patricia tree used in substrate databases is base 16. So let's look at it again. Imagine you have, so all these boxes that you see are nodes. Every node can have up to 16 children. And you put some values, you traverse the path, you go to the next, and finally you get to, let's say, you want to go from the first 7 child, A77, then you go here, you get D3, and you get this, where you get 03. Right? So to get to this value, you have to traverse 4 nodes. I'll pause here and just let you look at it for a bit. You can ignore the prefix part. That denotes like what kind of node it is. There are multiple kind of nodes we can have, depending on if it's empty child, if it has children and stuff. But let me know if this makes kind of sense to you, how we traverse the path. Important thing is this Patricia Muggle tree, it can have, I don't know the word for it, but there is a type where you have only one character, one value, but here you just fill it as much as you can. Yeah.
Is there any way you would try to keep this Patricia tree like balanced, or is there no need?
We'll go through that. How we make sure we keep it balanced. You will see this. Okay, so how does Frame create storage keys? Oh, there's a delay, sorry. Roughly, you have a storage in your palette. What it will do is hash something plus hash something. So it concatenates multiple hashes together to create a key. And for your palette, what it will do, hash of the palette plus concatenate hash of the storage name. You can already imagine you can extend this. We'll see more example to this. So yeah, and where does the palette name comes from? In your construct runtime, you give the impl struct of the palette some name, system, example, whatever your palette is. This is like kind of an alias to that impl block of your palette, right? And so your storage name is, the storage key is derived from this name plus the storage name. We will see more, just something to remember. So what kind of storage Frame supports? You can have a storage value. The thing that we did in the frameless where we did set value. This does not have key. This is just doesn't have key as in your code. You don't put something against its account IDs, right? You have some value that you put at some location. You have storage map, which is basically key 1 value. You have counted storage map, which is kind of extension of storage map, which just also additionally keeps a counter of the total number of values in your map. You have storage double map, which is key 1, key 2, value. And finally, you have storage n map, where you can have n number of keys. So let's go over storage value. So this is the way this is your storage value. Actually, let me show you first how you define it in the palette. Yeah. So to create a storage value, all you do is put that attribute macro on the top, palette storage, type, item, generic over T, storage value. You see some other things inside it. We will see what they are. But this is your syntax to create a storage value. Everything else is taken care for you. We will see what exactly it does internally. But for you, this is all you have to do to create a storage value. And you, in a higher level abstraction, you can think these storage just belongs to this palette. Of course, internally, some smart, clever things are happening. So what is storage value? What does it take? It takes some prefix, some value, some query kind, and also something called onEmpty. What are these? Prefix is what we saw before, like some prefix for all your storage keys. So it comes from your palette and your storage name. How do we generate? So we generate somehow this palette prefix and this storage prefix. And we will see how we generate this more. But roughly, it's just your palette name from the construct runtime. So you create this storage prefix. All this is generated for you. Let's see, actually. Yeah. So what we need is to create this storage instance and implement it for prefix. Okay, maybe I'm not explaining it well. Let me see. Yeah, so when you put that attribute macro, if you remember at the top, it automatically generates this code where you have some storage prefix that comes, my storage comes from the name of the storage value that you put. There is a palette prefix that comes from the name that you put in the construct runtime. All this frame does for you. And then it has this function prefix that is generated by your palette prefix plus storage prefix. This storage, again, the name of the storage, the name of the palette. Sorry, I think, is it clear now or is it too rumbly? Or should I repeat the whole thing? Oh, okay. Okay, maybe we can pause it here. Do you have a question? One final question? Or I could take it in the break. Maybe that's better. Okay, let's take a break and let's continue after the break. Okay, welcome back. Let's resume. Kind of want to finish this in 1 hour so to leave enough time for Alex for his lecture. Settled. Okay, let's resume. So storage value. Let's look that again. You need to give it a prefix, which is your storage key, right? Which is generated from palette prefix and storage name. It also takes value, of course, something called query kind, which basically tells you if you want to default to some value if the key does not exist in the database. And there's this onEmpty, which what do you do if it is empty? What do you return? Not super important, but we will look at those cases as well. So what happens? You define your storage value with that attribute macro, palette storage, and it generates for you. You could actually spend the time to look at the test. So what it is doing. Again, test externalities. You have to put all runtime code inside that. You try to get this item one that you defined on the top. It's none. You put some value, you get the value back, right? This is all you have to do if you create storage value. But what Frame does internally is it creates a struct prefix so when you, if you see storage value, the first parameter is just underscore, which is basically it defaults to something. and the macro generates this prefix for you. So what is this prefix? It generates this prefix that implements this storage instance. And this is basically the code that gets generated. Some way it figures out what is the storage prefix that comes from your storage map name, storage value name. The palette prefix I showed you in the construct runtime, somebody actually asked me, so I will just go back and show you this again. Yeah, you will see this more when we look at the code, but this construct runtime is where you define all the palettes that exist in your runtime, and you give it a name, alias to it. So basically, it's the alias to the impl block of the palette, right? So this is the palette name that we use for the storage. So what do we generate then? If you're gonna try and do item 1.hash key, that is the key that we generate. It will be like this two things. First is the hash of example, the palette name. The second is the storage value name. So this thing, the hash key is just concatenation of these two hashes. So by default, all storage keys are optional. Either it exists or it doesn't exist. But let's say there are some cases where let's say balance. If the balance does not exist for a user, you want to default to 0. You don't want to always unwrap and do something. So there are ways to hide this internal thing and make it return something by default. You could use other APIs that storage value has and other types of storage as well. Exists will return if it exists or not in the database. There's also try-get, which is like a result. Right. So we saw this query kind also that storage value takes, right? It's like a non-mandatory field. You can skip it and then it defaults to option query. But if you put it value query, what will happen is if the value does not exist, it defaults to whatever the default value of U32. So in this case, we said value query, and then when we try to get some value that does not exist, it returns 0. There is also another type that you can pass your storage value on empty, where you can create your own default implementation and stitch up that. So you can, I don't see why you would ever have to do this, but you can have your own default value and you can say my default. And then when the key does not exist, it returns 42. Yes.
Like when we say default value, is it like the same in Solidity where we have like by default a default value for each type, or we have to like to set it
So if you don't set this parameter, your type should have a default. That it should implement default, right?
I have to do, or like
I mean,
the
for a lot
language will give me like the default value for this
It's normal Rust. A lot of primitives have a implementation of it already. If you have a custom type, you will have to implement or derive it, which automatically derives it. If you have some special case, you can do your custom default implementation as well.
The second question, do we have a way for safely upsert in the storage itself?
Safely absurd.
If it's not there, so like just add it.
Yeah, I don't know. But we can look at the APIs together.
I don't
Do you
think-
know the answer? Yeah.
I don't think there's a pre-written API for it, but there's various APIs that make it fairly easy to do upserts.
So internally, even if you do value query, what exactly that is equivalent to is doing something like try get and doing an unwrap on it and defaulting to some value, right? You can do this manually by yourself. This is just a syntactic sugar. You could, if needed, you don't have to unwrap it all the time. And if you know that you don't care about the value exists or not, you can default to some value, right? I would say generally preferred thumb of rule, you should not do that. But in some cases, maybe it's okay. So there are two ways to set or put value to set the key to the storage value. You can use set or you put. So the set always, you have to wrap it in some or none. So if you set it none, basically it will clear it. If you set it to some, you provide some value. Put does not need to do that. So if you set put, you are setting some value. If you you cannot set it with put, you cannot do it as cannot clear it, right? So you're not wrapping it some. It's doing that unwrapping for you. Sorry. So with set, you are saying this value should exist, some, and what value it is, right? If you say none, it gets cleared. With put, you just say a value and it gets written to the database. You should never put or have your value as option because it doesn't make sense. Value not existing means basically the value it's none, right? If you do this option, basically you are unnecessarily setting something on database that you don't need to. So basically, if you say option and you set it as none, so let's look at this example. So if you set the value as option of something, you could put it as none, and that value exists in your storage, right? You're inflating your data, and you should keep it as minimized as possible. So this does not make sense, and yeah, don't do it. There are also cases where you will want to set some key to figure out if something, so it's like a flag. You want to say, oh, something happened, so you set some Boolean, right? You want to have a key where you set a Boolean. But all you can do is, instead of a Boolean, just set as unit type and check if the value exists or not. If it exists, it means true. If it does not exist, it means false. And this also means you never have to decode the value, take the value, you just read whether the key exists or not. There are ways to remove the storage. Two ways you can see is either you can kill it, or you can use something called take, which kills it and returns the value that you can use in your logic. What do you think is cheaper? Kill or take? Sorry? Kill? So yeah, kill is cheaper because you don't have to propagate the value from the database to the runtime, right? There's also this nice way to mutate a value. You can always do get something and then put Or you can use this API where you mutate, you have a closure which acts on the value, and you mutate it and set the value. And if it's a, yeah, this, yeah. So at the end of the block, whatever is the new value of X is what is in the database. There are times when you want to do mutate, and if some condition fails, you want to skip updating it, right? So you can use try mutate, where if you return an error, nothing gets committed. Okay, in your test, you will probably want to do a lot of assert error. Instead, what you should use is assert no op. It's basically assert error, if you see the code, but it's doing few extra things. So whenever there is an error, you also want to ensure that there has been no storage changes, right? And this generally happens not inside a call, but if there's like an internal function that gets from one palette, you can call other palette, and it can do some data changes, and the whole thing succeeds, but this palette gives you some error. So just know that still there are cases where you can do some storage changes by mistake, and so you should always use assert no op, which also ensures that state code has not been updated. Yeah. Oh, sorry, but this Alex or Oscar?
I just want to make sure I get it correctly.
Yeah.
Here we are dealing with, we are implementing our own blockchain. So the idea of if one of my transaction is reverted, the whole transaction is no longer there in the smart contract context. It is different, correct? So I have to make sure if I, in previous step, I like updated the database, I'm clearing the values. Is it correct here, or is it different?
No, let me show you some tests. So does it have? No. So let's imagine you have a test where you try to call some function. It could be a call, it could be just internal function, and it returns error if something fails, right? What you can do is assert error. If you call this function with these given scenario, it gives an error, which is intuitively okay, fine, but you can do better by saying assert no op, where in addition to saying, okay, yeah, there is an error, it asserts on error, it also checks that it did not make any changes to the storage.
Yeah, this is my point. Like here, I'm not relying on, I'm reverting, so everything is cleared. I have to do it manually.
Yeah, so anything that returned error should not change state. Yeah. So sometimes you will see in the substrate code, you will see actually this in few relation palettes. We have this palette unbounded attribute macro on top of the storage value, storage map. This is not good. We want all our storage to be bounded. Again, constrained environment. We want to make sure we have some bounded computation time and proof size, right? So what you should, so basically if you use vec of U8 with no bound, that's unbounded. But what you can use instead is a bounded vec, where you, so how do you, what is a bounded vec? You say what kind of value it is, and you give it a constant that determines the maximum value of that vec. And this is what I was talking about when I was talking about the get rate, that you can kind of compile time inject into your palette. Okay. So So next is storage map. Is there any question before I go to storage map? Yeah.
Hi. I do have a question related with mutate. In which scenario we should prioritize to use mutate instead of try mutate? Since, I don't know, if we're trying to be defensive programmers, we should prioritize the error handling happening in the try mutate, right? So in which scenario we should use this instead of the other one?
I mean, it depends on your business logic. So if you are doing some mutation that you know that can never fail, you do maybe a safe math, you do saturating add, right? Then you can use just normal mutate. But when you know that something you are doing depends on some condition to match, you do time mutate. So yeah, it depends on your logic.
Can you explain the part where we were using a asset different equation?
This one?
Yeah, where we were checking whether my database like storage has changed or not due to some error. Like, in what example or scenario would I need this, or is it always a good practice to use this nonetheless?
Yeah, I think it's good practice. So this happened to me actually once. You generally assert on some calls which are already transactional, so it will never happen, right? But I think there was some scenario where some palette call is dispatching to another internal, like another palettes function, which is not via a call, and that would change something. And so okay, so there is a palette which has no callable. It's just some logic, right? And then there's another palette that kind of uses this palette to do some things. So the first palette that does not have any call, you want to write unit test for this as well, and it has no callable. And so now you could do sometimes some things where you are changing state, but you should not. You should, like, if you're erroring out, you should never do that. So yeah, we kind of make it easy for you by defaulting that every call is transactional, but still great practice to do this because you don't know what can go wrong, right? It's, in a way, it's a defensive programming. Yeah.
I'm just wondering if Frame has any APIs that enable me to revert all my updates instead of like having to keep track all like the edits.
Yes.
It's similar to like what we have in .NET, for example, like when you have like you are adding to as if you have an open connection stream to the database, and then by the end of all the edits, you are like doing apply changes or save updates or whatever.
Yeah, so that is what your transactional layer is. So maybe it didn't go too much into it yet, but basically you can span your own transactional layer. So yeah, call is transactional by default, but you can spawn your own transactional layer. You can do some things, and you can discard it if you want to. And that discards everything, right? And that is where you can have nested 256 transactional layers.
So just a follow-up, what's the last reference value against which we know that the storage value has changed? Like, is it n-1 or like it goes?
Sorry, I didn't get it.
So let's say I have several changes, like I call a transaction, like palette that calls a palette and like etc. So what's the last reference value against it checks that, okay, this change has been done?
So it depends on the transactional nature. So if you make a call to a call function, which is transactional in itself, all this are in one block, right? So it depends on your transactional block, right? You can create your own custom, and so that would be the minimal thing that will get reverted. That will be your last reference point. So it depends on your logic. It depends on, in a normal case, you will do probably a call, and everything that you did in a call will be reverted back. Okay, storage map. Similar thing, there is prefix. There is something called, there's a hasher now. There's a key. there's a value, and same things again, query kind on empty. There's also something called max values. We generally don't use it, but there is this, if you, something for you to know. So what is the hasher? I told you that the hashed key comes from the palette prefix and the storage prefix, right? Now you have key value pairs. So by default, maybe by intuitively, you can imagine that you want to hash the key as well and put it in this hashed key. So yeah. So now your storage key would be palette prefix, storage, and key. So you hash the key with that hasher that you provide. Do you guys have any idea why we want to hash this key? Yeah. Yeah, sure, go for it.
We are hashing to make sure like we have a fixed keys, like fixed length, I mean.
Actually, it's not really fixed key because if your key is long, the hash would be long. It's not a fixed key here, at least for the hashes that we used. Yeah.
To avoid a arbitrary balance of the Merkle tree.
Exactly. So we want to avoid unbalanced trees. At least the unbalanced tree that can be triggered by some user path. Yeah. So let's look at an example. Similar, there's you put the attribute macro palette storage. You say storage name item 9, which is storage name. You give it a prefix, which again you're defaulting by saying underscore. You can technically create your own prefix. You can implement your own custom prefix. It breaks some frame standards, but you can do it if you want. You give it a hasher for the key. You give the key type. You give the value type. Yeah. That's all. For the storage map, this is all you do. Yeah, so the hashes that we use, these are all the hashes that we support. There's identity, which is basically not hashing at all, directly using the value. There's Blake 120, Blake 2 128, Blake 2 256. So these two are like secure hashes where the distribution is like random. So it kind of avoids the unbalanced trees. There are 2x ones which are non-secure, which means there is an attack vector. You know, some user can create like specific keys. Let's say there are account IDs and it generates only IDs which are going to create unbalanced trees. There are two more hashers that we will look at the end of the slides, which are special, and yeah, we'll see why it is special. Yeah, you can also have value query. So balances is a great example where value query kind of makes sense. If the value does not exist, you just want to default to 0. See what's doing. Yeah. You can just look at the code.
Can I add a?
Yeah.
So there was a question of the transactionality. So transactionality has been around for a while, but I'm going to date myself by speaking about what we did before we had that. And what we did before was this pattern. And this pattern is, so try mutate gives you a kind of transactionality for one particular storage key. So if you want to change more than one storage key, you need to kind of nest these try mutates. So the try mutate will, on OK, it will commit the particular value you're mutating. If you return error, it will error out and discard the change. And so if you need to change two balances, a transactional way without using the transactional storage layer would be to nest these two, and this sort of showing this pattern in storage and how it might look in practice.
Actually, you can also see that if you were not using the value query there, you'd probably have to unwrap this to balance and default to some value and stuff like that. So in these cases, this value query makes a lot of sense. Also about the point like this closure thing, yeah. Okay. Now you saw that we are doing this this very intentional way of organizing our prefix trees. We are saying we are kind of distributing it with palette name, storage name. So what does that give you? At the end, you can see, so if you look at the storage root of some normal substrate chain, this is how it will look probably. You will have some balances palette where there are like a bunch of accounts, right? Is this bad? Is this unbalanced? Is it bad? Any ideas? Any thoughts? Yeah? Here, on the front.
So this one in particular is unbalanced because we have too deep nesting on the right side, and we should balance it from the root.
Okay.
But
so let's think about it. This is the unbalanced nature is okay. Sorry, there are more answers.
Yeah, so this tree is unbalanced, but it's actually something that we want because it's grouped. It's
Exactly.
easier to get to this.
So this
account.
is unbalanced by design, and it's not a user attackable vector where the user can create unbalanced tree which we can't control, right? So here what is happening? If you did this thing at the storage root, if we didn't segregate our palettes, there will be a lot of accounts, and then the hops to get any other palette storage value would also increase, right? So basically, a lot of accounts will increase the computation time for other items as well. With this, only when we want to read account, you have to hop this. And also, that is also very fixed hops, like 2-3 hops extra, and then it's all just balances, right? So unbalanced trees can be bad if it's non-intentional, when there's a user attackable vector where user can somehow influence the keys and create like unbalanced trees. Here we do it intentionally, it's by design, and it's pretty nice. Yeah, going on to the example of how the hash keys are. So item 2, yeah, item 2 was totally different storage value, and so it had some same palette, different storage map. For item 10, 2 values in item 10, you have this 2-part common, and the key is what is different. All this is making sense, right? Okay. Arranging it like that, this intentional unbalanced nature of the tree also gives a way for us to iterate over similar values. So technically, you can go and iterate over all accounts under some key, right? So let's see what's it's doing here. So we have this API, next key, you say previous key. Yeah. Basically, you tell the part of the prefix, And then you should be able to, yeah, basically it's just going one by one to the next one, right? So you're basically iterating over all the keys under one prefix. Yeah.
So, do we also reorg like inside the accounts to keep it unbalanced sometimes when like accounts with like zero or close to zero balance or like not being used for a while, or like system generated accounts like treasury, etc., which are used a lot? So is something like that reorg also happening?
So there is no reorg. You define your hasher, and that's how it hashes. It's kind of fixed. You can migrate, of course. There are ways to migrate it if you think there was something wrong, there was a bug, and you migrate. You iterate over all the storage in some migration and move it to another prefix with some different hash, right? So you could do that. But yeah, I'm not sure exactly what you.
Sorry, I think
Yeah.
I was talking about the prefix tries. So inside that, we are keeping it unbalanced, like on the top level, right? So do
Yes.
we also keep it like unbalanced on the accounts as well? Like,
But no, that's the point. So as a dev, you want to hash the keys under the account with a secure hash, with a hash that is like randomly distributed. So it can be, it should not be unbalanced. If the hasher is not secure, then user can kind of influence and create keys that would be unbalanced, right? It would maybe lean on one side, right? So yeah, as a dev, your job is to make sure to use correct hashes, to make sure to understand how this all works, and make sure you define your storage values, storage maps, keys correctly, right?
good, thank you.
Yeah, just a code how we can iterate over all the keys inside one prefix. You basically filter by something that starts with some given prefix, which is, let's say you want to go over all the accounts, you did palette name, storage name, so balances, accounts. Yeah. What does that mean? Sorry.
25 minutes.
Ah, okay. Yeah, something you can look over by yourself. Let's see. So if you start with the prefix empty, it will iterate over all storages. If you start with iterating by just the palette name, it will iterate over all storage values, storage map, everything inside that palette prefix. Similarly, you go as deep and then iterate over it. And this is only possible, again, because of the intentional design that we have. There is one problem, though. If we iterate, we don't really know the key. We only have the hashed keys. We don't have we cannot, so if it's a secure hash, we cannot get back the old value, right? So we iterate, but we don't know the keys. And I think this was an issue when we did some kind of migration at Polkadot, where we needed to migrate some storage from some other place, and you can iterate over it, but you don't know the key, and how do you now migrate, right? Make sense? That you cannot get the key when you're iterating. You only know the key, and then you can get the value. So if you start with the key, you have the key. But if you don't have the key, if you're just iterating, you can't have you can't get the key associated with the values. So what we can do is we can use something called transparent storage keys, and we'll see what it is. So these two hashes that I showed you in previous slide, they are called basically transparent hashes. Why? Because what it does, it hashes the key, and it also concatenates the actual key, the unhashed key. So pre-image is basically the thing before you hash it.
Okay, thanks.
Right, so what's happening? Hello is hashed as this. Blake So hello hex is this. You hash it, you get this. With Blake to 128 concatenate, you have this part until 1b, let's say this, concatenated with the actual key, the hello, this part, right? Basically, we are keeping the actual key also with the storage key. So now if we use this hasher, we have access to something called iter. So basically when you choose this hasher, it implements another iterable storage map trait, which then you can use to get both key and value. So if you look at the return value of iter, you get both key and values. For the one with opaque hasher, you cannot get keys. So which hasher to use? Yeah, I don't know when you should ever use identity. Okay, yeah, you can use identity if you have already by yourself hashed it and you know that it is correct or it is like randomly distributed, then you can. But in general cases, you should never use identity. You can use 2x64 concat when you think, again, like account IDs, they are actually secure hash. They are randomly distributed. It's hard to find a way to unbalance it. So you could just use 2x64 concat. But in general, if you're in doubt, you should always use break to 128 concat. Basically, this is a secure hash. It randomly distributes. You kind of guarantee that, yeah, your try will be not unbalanced.
So for your assignments, pretty much use Blake to 128 concat. It should be the default.
Or if you're using 2x64 concat, write your reason in the documentation.
Yeah, if you use something that's not Blake to 128, just say why. But in general, just use that. There's no reason to use another one in your assignments. I mean, there might be a reason, in which case tell us, but you're fine. You're always fine with Blake to 128 concat. The only benefits you get by using the other ones is like a little bit of performance. You can do so if you feel inclined, but the default is always going to be okay.
Yeah, it's around the same thing that we have already discussed. We want to avoid unbalanced tries, so use Blake to 128 concat. Yeah, just read it. There is also a documentation that is linked in this slide. So yeah, read them, understand what APIs you can use, try to use them nicely, look at other palettes, see how you can also use it. Okay, what next? So there are two more types of storage that you can have. Storage double map is when you have key 1, key 2, and a value, and when you need it. You need it if you want to categorize something or store something which has like asset ID, account ID, and some balance. So you have multiple assets. I think you have some, but there's assignment for multi-asset treasury, right? So probably you will need this double storage map. There might be cases where you need, I can show you later, there is somewhere we use a staking palette where you might need to have more than 2 keys. So you can use storage nmap, which is basically the key is a tuple of multiple types. And you can go on. So you can have as many keys as, I don't know if there's a limit, but yeah, I don't think have not seen anything more than 3. And you add basically hash. So yeah, if I show you the code, actually, it'd be much nicer. Yeah. So this is how you define your storage nmap. You give it key, and for each key, you define the hasher and the type. So generally, you should never do iteration. If you think how expensive this is, so every every storage that you read, that is basically log n. If there are n items, that's log n for a balanced tray. If you have n items to read, that's n to log n. You also have for each node 16 children, so that's 16. So basically, you're doing very high computation that you should always avoid. I don't see any case where you will have to iterate over whole map. There are cases where you want to iterate, inner palette hooks, you want to do some cleanup, some things, and what you can do is do it in a bounded nature. So I think here it says here, right? So make sure that you, I don't know, do 5 or 10 or 100 items at a time. How can you do it step by step? So there are APIs like remove all where you set a limit. And so you kind of keep calling this every block. You set a limit to 100. You do only in a bounded way. Counted storage map. This is pretty cool. I would suggest to use always counted storage map. It's just again, syntactic sugar. What it does is, along with a storage map, it also creates another storage value, which is called counter for whatever the name of your storage map, and it keeps the count of the value. So whenever you insert something, remove something, it keeps track of the count. But this is not important, but I like looking at these numbers. It's, yeah, in a production chain at least, so pretty nice to have. Okay, how do you design your storage? Either you can, let's say you have some list of items. Either you can put it all against separate keys, so you have like multiple keys, or you can keep all of them together like a large value, right? Thing is, both can be bad. It depends a lot on your use case. So if you need to read only 1 or 2 values at a time, you should always break it down into small values. If you need to read, let's say there's a bounded list, so there's a if you're doing staking, there's like 1,000 validators and it can never increase more than that. So there's a bounded nature to the items. You could keep all of them together, especially if the read requires you to read all of them together. So it doesn't make sense to make 1,000 reads, have one big item, read everything together. Yeah, I think, yeah. So let's go over it again. Oh. Okay, there's a delay. I'm on a different page. So let's take a scenario. We have millions of user accounts, all of them doing transfers. How should you design your database? Anyone wanna have a dig at it? Yeah, there's in front.
In a tree? Yeah.
So how do you design your storage? Will you have, I don't know, storage value with million users? Will you have storage map? Will you have storage double map? How do you design if this is your scenario?
So maybe in a map.
And what is the map? What's the key and value?
The key could be an account ID.
Why do you do that? Like, why not put everything in a storage value? I don't know, like couple of storage values with all the million accounts.
because then you need to iterate through all of them, and you
Yeah.
somehow need to know like which value is which account, and it's harder.
Yeah, so this makes no sense what I said. I mean, you only access one, maybe two accounts. There's a transfer, maybe some weird case, you need 3 accounts that you access. You don't care about the other accounts. So you only access those accounts. So it makes sense to break down your data into different keys, different key values. Yeah. Yeah, already talked about this. Let's say you have 1,000 validators that you have to read and put it in somewhere. They are the next set of validators. You always have to read 1,000 validators, and validators is like a bounded set. You obviously should just use a storage value, right? Storage value of bounded vec. Anybody want to disagree? Or? Okay. We need to store some metadata about the configuration of each validator. Anybody want to answer? Yeah.
So for each key of validator, we store in a map the metadata.
Yeah, in this case also, you will, a validator will change their preference one at a time. You will not all validators will change together, right? So what I want to convey is how to design your database, like your keys, your storage, depends a lot on your business logic, your read and write pattern, right? You need to optimize for whatever is, if it is read heavy, you optimize for read. If it's write heavy, you optimize for write. Okay, so we covered a lot. What is frame storage? Just simple set of macros that does a lot of gluing to do a lot of things for you. For you, it just becomes abstraction where you think, yeah, there's a palette, there are storage that is related to that palette. I think somebody asked like in previous lectures that, can you make the mistake and write to another palette? Do you see that you can make that mistake non-intentionally? I mean, I feel like that's almost impossible here, unless you literally want to do it intentionally. Okay, so we also saw this iteration and stuff. It exists does not mean you should use it. There are things that are usable in tests, usable maybe in extreme cases where you need to do migration and stuff, and you still have to think in doing this in a bounded nature. So just because some API exists, you should not use it. And just because some API does not exist, absurd, does not mean you cannot do it. You can do it. You can create your own some syntactic sugar. Or you just do get and put, and it's all fine, right? So with these primitives, I believe, I don't see that anything that you will come up with that you cannot cover, right? Okay, with that, we are done with frame storage. We can take a 8-minute break, right?
Yeah, or any last questions? And then I would, say a few minutes.
Yeah, I can take the question also. Is there any question? There's a question.
Hey, maybe it's a dumb question, but I recall that that someone mentioned that we only use standard library during tests, but not into the actual implementations. So as far as I recall, the iterator traits comes from the standard library. So there's like a custom trait for production ready environments or something like that? Or
so everything that you see that you use, we never use the standard library, but a lot of things from the standard library is re-exported via this SPSTD, right? And whatever is in SPSTD is safe to use. If you try to use a STD IO library, basically it will not compile. If you try to compile Revasam, you will get errors. So, yeah.
That's the regular standard Rust library iterators. It's just traits, so.
Okay, thank you.
Let's give it up for Ankan pulling through.
Hello, everyone. You're probably a little bit tired from the long morning. Thank you for still being here. I'm taking over, and I want to talk with you about construct runtime and testing. Let's have the chats later in the break, please. I'm a little bit strapped for time, so we'll have to see whether we can fit the whole lecture in the morning. We might have to spill over a little bit into the afternoon, unfortunately. We'll see. Guys, can you please go outside if you continue to have your conversation? Okay. Would I like to what? Touch me? I don't know. Okay. I can use your computer. Yeah, it's fine. Technology.
How many blockchain engineers does it take?
Yeah, that's not my expertise. That's why. So, if this were running on the blockchain, it wouldn't.
If this wasn't Substrate.
I think a thing that I can already say is about the title of the thing. I said construct runtime. You've heard that phrase a lot because it's the name of a macro, but it's actually an old macro. So one of the things that I will talk about is. It's in the Lucerne. It's updated.
Yeah.
The PBA and not Lucerne. That's right. Okay. Then I can't have my notes. I won't have notes. Okay. Yeah, so it's called construct runtime, but that's the name of the old macro. But we often use it, so it's easier to reference. Runtime macro would be maybe another name for the new one. But yeah, cool. All right, so we'll start with the runtime construction, construct runtime, and then this is basically a two-part lecture, and we'll see whether we have time for the second part in the morning or whether I have to spool over. So you know this image, you've seen it a bunch already, right? And basically today, right now, in this talk, we'll focus on this part. So tying all the palettes together in order to form the runtime. And the runtime is kind of two things. So the main thing that you've already seen, you've seen the T config, right? And you've heard the reference of like, here we expect a type that implements the config. And that's the runtime. That's the runtime struct. So that's one. And then apart from that, there is a kind of, I would say it's related to the first part because having the config of all the palettes is sometimes important for this, but it's a type that helps executive implement the runtime APIs, or that helps you also implement runtime APIs. So you might even add a custom runtime API, and you will probably use the runtime struct in order to then implement it. Potentially, it depends. You definitely will use the outputs of the construct runtime macro to implement your runtime API. So there's actually, we need to make a distinction. We use the same macro, but it has two different use cases, the runtime. One is the mocks that we use in testing, and they're simplified. They're mock runtimes. They have mock configurations, so we might not use a hash for the account ID, but instead use a number. We use simplified. We have fewer palettes in there, potentially only the ones we need. in the mock runtime, and then we have the actual production one, which will be in the runtime librs. And here you see the new syntax and the old one. So this is the old syntax with a bit more like of embedded language kind of flavor to it. And then the new macro sort of goes along with that. You've heard this, that we want you to write Rust, and we want you to write kind of idiomatic Rust as much as possible. And the new macro is there to make the flavor of using it much more idiomatic Rust and much less mysterious. So it's more obvious what is happening, and you're less confused of like, where did this type come from? So that's why we have the new one. And so we'll contrast them. You need to know both because you might encounter the legacy syntax still in the ecosystem floating around. So I think it's still good to see it. So that's why I put both there. And we can compare the two. You can see that the old syntax has the advantage of being a bit more concise, right? Because, yeah. But the disadvantage is that that some things are elided, that it's good to specify. So we have the runtime struct. And this is sort of the one thing that will get all of these things tacked onto it. Oh, yeah. So it will implement all of these configs for all the palettes, right? In our example here, it's like, I think it's very few because I wanted to make it not, explode, but in a production runtime, it might be dozens of palettes potentially. So anywhere in your palette code, you can then use the runtime here to do things like access the block number or access an account for a storage map or some other storage type. And so it's this, right? It's this dependency injection system that we have going here, where this runtime type can be used to put it everywhere. So now we get to the actual palettes that we're including in our runtime. And you can see here that we use, I wish I had like a stick or something. Do we have a stick somewhere? We have the index, and by convention, I think frame system is index 0. And one of the differences between the new and the old syntax is that here you see that the index was optional. And we decided that this was too much of a foot gun because if you change the ordering here, it will auto-generate different indices, and that's one way to break. Because you just learned in the storage lecture that we use the name of the palette, and sorry, you learned in a previous lecture that we use the index for the call to sort of index into the call, and that means that it changes the transaction format if you change the index of a palette here. So that's why in the new one, it's obligatory to add the index. I think we have not mentioned this. This is a good time that there's a runtime version struct that's in your runtime. And you have a field there actually that is called transaction version. And so if you had to change an index, a palette index, that would be one reason to bump the transaction version. So things like offline wallets will know that they can no longer sign transaction, like the transaction will be rejected if an offline wallet tries to send it with the old format, because it needs a new format, it needs new metadata because the indices have changed. There's a question there. Can we get a microphone there?
I'm just wondering, let's assume I'm implementing the runtime from the palette itself, and I'm adding my own custom fields, and by mistake or intentionally, I use the same index twice. It will be revert. It should revert in theory. It will be. I will detect it in the compilation, like during the compilation. Okay.
Yes. So the macro will complain during compilation that you're trying to assign the same index twice. Yeah. Cool. Yeah, so versioning, very, very important. The transaction version, we can come back later to it. I don't have the code here to talk about it in detail right now. Just a point that it's relevant for this. It's connected. And then, right, yeah, like you can choose any name and you just put the path to the crate there in order to define your own palette. So under the hood, this generates something nice. It generates a type alias. So the name is not just used for the storage as a prefix. It's also used as a name that you can refer to within the runtime librs. So if you're not using the runtime to implement runtime APIs, you might use a palette to implement the runtime API, right? If you wanted to give access, if you had a DPoS runtime API that would allow outside the node or outside clients or whatever to access information about your DPoS palette in a way that you want consistent and sort of like, yeah, as an API over time, then you would potentially use this one to sort of connect the two together, your palette and the runtime API. So then you get nice things like you can say system block number and system account and so on and so forth. So the next one is something that we've already touched indirectly. You've seen the impl for tuples thing. We talked about this earlier today. And this is one place where it comes into play that's very important. So a type is generated that's called all palettes with system. And it's this tuple that we can then iterate over and call the hooks on. And executive, we'll come to that in a moment, but executive will need this in order. Yeah, that's there on this slide. Yeah, it's used by executive to dispatch the palette hooks. So this is generated by the construct runtime macro. So this is 2 lines, and I guess in here is missing, do the actual block execution stuff. We've talked about the outer enum, right? Construct runtime is also the one that generates the outer enum types, the runtime types: runtime call, runtime event, runtime origin. So we see an example here. We have a palette call, and then this is just basically a recap of the outer enum stuff, just connecting sort of the different things right? Oh, we're doing the construct runtime here. Oh, the construct runtime is doing the stuff that we've talked about in outer enum, creating these enums. So the old syntax had palette parts. So you would, by default, it will just include all the parts. But if you wanted, you could pick and choose. And you could say, I want the palette struct, and I want the call and the storage. But it's not a good example here, but like on mine, I don't really need the event, so I'm going to leave it out. Or actually, my palette doesn't have any calls. So the old syntax allows for that. And that changes the outer enum type. The new syntax does not allow for this parts thing. I think my guess is, I actually don't know, but my guess is it was too much of a foot gun because it would lead to very confusing errors. And so instead we added kind of a blacklisting, kind of like, oh, I want to disable this thing specifically.
Yeah. So you usually, there are some things that you don't want to disable, or maybe you don't want to disable at the same time. So now if you specifically want a palette, but not for its calls, you can use this disable call.
Yeah, we're getting to that.
Or something specifically. But yeah, and you also need to annotate it, not use the other syntax, which was weird Rust. So yeah. The functionality is still there, but now it's easier to use. I mean, maybe not less keystrokes, but more understandable when you read the code.
Yeah. More understandable what's disabled, because by default you want to enable the things, and harder to shoot yourself in the foot. I think this is recent-ish. It's like, it's not recent, but like, it's not super old. So if you run into trouble and you're like, oh, I really want to disable this part of a palette, that's a feedback that you can give to the frame team and say like, hey, I really need this to be able to disable this for whatever reason. And you can tell them.
What do you mean? What do you mean? Sorry, that it's not implemented, or?
Yeah, like so the set of disable tags is limited, right?
Yeah, I think so. Yeah.
And it was a while ago, like I don't know, 1 or 2 years ago, but
Yeah.
it's not been around for super long. So there might be a case that was missed, like a subtle thing of like,
Yeah.
oh, I want to disable this particular thing and it's not implemented.
So construct runtime v2, like it was already implemented a long while ago, but it will take a while for everyone to use it.
Yeah.
All our templates use it, but some code still uses the old construct runtime because it's more of a legibility thing. Like the functionality is exactly the same, so
Yeah.
it doesn't matter if you're using the old syntax. So
Except for things like this, where it's a little bit easier to shoot yourself in the foot with the old syntax.
and also with ordering. So
Yeah.
in the old macro, this is very irrelevant if you're using the new macro, but in the old macro, there are two orderings. There's the index of the palette, and there's the order. So the order determines the index, but it also determines the order in which the uninitialized hooks are called. So you can like reorder the indices, but if you don't reorder the actual types, it would absolutely break. Now it's all done by index. So it's, again, harder to shoot yourself in the foot.
So recommendation for production, use the new one. For tests, feel free to use the other one. There is a question there.
You forget it.
You get your own personal microphone.
I just like confused because like when we disable, we add the attribute to disable like certain, are we disabling the, like for me, this is what I understand. We have an enum for the runtime and we are adding whatever palettes we want to have. So why should I disable after adding it? Or we are kind of like disabling some features in the palette.
Yes, so if you do disable call here, this particular one, so an example use case. You have a palette whose functionality you like the storage layout, works well, but you don't like the extrinsics it provides. You don't like its calls. It's not a good interface. You don't like it, you don't want it in your runtime. A thing that you can do, which I think we'll probably talk about more in detail, is you can write a second palette that extends the first one. And that extension palette will, you code the calls in the way that you like it, right? You write your own interface on how people should send transactions to this palette. And then what you have now is you have two palettes. One is the storage and the bare bones thing. And the second palette will have the calls for this first palette. And now, of course, you don't want people to use the calls of the first one. That was the whole point of extending it. So that would be one use case where you would do like, okay, disable call for the first palette because you're just using it for its storage.
And disable call is a function, or how can I know the kind of feature that I can disable or enable? Is it from the metadata?
Read the docs.
Okay.
There are docs for the runtime macro, and it will say in the docs, hey, these are the things we can disable.
Yes, but basically, I don't know if you can do for all of them, but basically all the things that go into the outer enum, you can disable. So calls, events, errors, storage, like you can disable all of those things, I think, within reason. So yeah, check the docs. And you cannot choose to disable some calls. I believe if you want to disable calls, you need to disable all of them. Same for event error and so on, because it just controls whether or not it gets included in the outer enum or not.
There are other ways, by the way, of filtering calls, which I think we haven't covered yet. We will cover later. So there are other ways, but this is one very clear, like this palette should not be interacted with. So it's a very clear way of doing it. Cool. Let's keep going. Cisco already mentioned this. The ordering in construct runtime matters in the old macro. In the new one, it doesn't. And then there's something called integrity test. It's a hook. You will hear more about hooks in a later lecture. This ordering made more sense, whatever. You will hear more about hooks in a later lecture. And the integrity test is basically a kind of sanity check that is run for your whole runtime. And it is called at compile time. Is that right? I think it's called at compile time, right?
Yes,
Yeah.
it's called that. So it actually creates a test.
Yeah.
But it's just so that you make sure that there are no errors. But it gets called the compile time. It doesn't get included in like production code or anything.
Yeah, exactly. Yeah. So this is yeah. We'll get into it later more, maybe. But this is a way to test. Well, I guess it's a good segue maybe into the next section. This is a way to test the integrity of your configuration, which is compile time, right? So I would move on to part 2 testing. So this is the time to ask any questions you have about construct runtime. Is that a question? Yeah.
Can you go back to that slide where you were going through enum runtime call and you were looking at how it was expanded in different levels?
Enum runtime call. Expanded in different levels. I'm not sure. This one?
Yeah.
Yeah.
So I guess I'm just a little bit confused how. So we would expect that call to be implemented in each palette, and then the call that was like the enum would be implemented in each palette, and then the enum would be passed into the runtime call.
Sort of, yeah. So yeah, maybe this is not obvious from how this is formatted. So this is the code you write in your palette, the first one, right? You annotate your implementation of your palette with call, and that then triggers this code to be generated. This code that's generated is still in your palette. So there will be enum call in your palette if you only expand, right? There's this tool, I think we mentioned it, cargo expand. You only expand the code of your palette, it will include this enum. And you could call it palette call, but we just call it call, right? So that's going to be in your palette. Now, your runtime is a separate crate, separate Rust crate, that depends on the palette. Yeah? And in that separate crate, we also have a macro called the construct runtime macro. And that one will also generate an enum, and it will generate this enum. And this enum will include as the inner variant thing value, it will include the one from the palette that you pulled in as a dependency.
Okay, that makes sense. For some reason, I thought it was like an interface that was expecting in the enum, but okay, it makes.
No, I don't think so.
I
mean, there are interfaces that expect it, but it's the code, like, so, and not, so there are other aspects to the construct, like it generates a lot of stuff, and part of what it generates is the whole like dispatching thing, where like, right, we have this thing where like in the beginning there is this like encoded data and we need to decode it and then we need to dispatch and stuff. I think we talked a little bit about this in an earlier lecture. So no question, maybe you can pass the microphone.
No, actually, I just want to add, like, we have that system that's the first index of the palette, that's the enumeration, and you call the second enumeration of a call, that's the second index. So you have 0, 1, 0, 2, that's the shown with that. Yeah.
All right. How much time do we have? Oh, we have half an hour left. Let's try it. Let's see how far we get. Testing. So this will be very important for your assignment. So your test requires a mock runtime because admission time, if we're being really pedantic, we're not quite doing unit tests. Or if we're doing unit tests, but we're doing unit tests at the unit level of the palette, not really at the function level. It's like, what you're going to do? It's like the the state and the the functionality are quite closely entangled at the palette level. That's one of the design choices. It makes for these nice modules that are self-contained, which I think is really good for isolation, but it makes it a little bit hard. Like it's a database, so it's hard to write, functional code that's like independent of state. You can still do that, of course. You can have like proper, functional unit tests where you have a utility function in your palette that does some, math or something, and then you write a proper unit test that doesn't require any state except what you pass in. But most tests will actually test at the unit level of the palette. So for that, we need a mock runtime. And so, yeah, it's a unit test at the palette level, but the palette has dependencies, and so that's why we need to do that. But luckily, most things can be mocked. So we'll have, whatever, some account ID. We can just choose any one of the benefits. Because it's configurable, we can just choose a type, whatever, U32 for the account ID, and then block number, balance, and so on. And we want to supply values to these get associated types. I think you've heard a bunch about them today. I remember we talked about this, right? We have these gets for the configuration, and we will use the parameter types, which you've also already seen. So you can just use the same stuff that we've already talked about for the tests in order to create the mock. I think we have not covered this. There is a very useful, for constant values, for constant numbers especially, there are these const U32, for example, for the U32 type. There are these const values, and you can just plug them in. It means the value will be kind of anonymous, so it's like harder to refer to. You will need to use the config trait in order to be able to access the value in your tests. So, but if you don't really need the value and you just need it to be something, then it's an easy way. If you want to torture yourself, you can also implement it yourself, of course. It's just a trait. So Genesis. We have not talked about Genesis yet. So you might want to inject some state into your palette at start time, at Genesis. And for that, there is a Genesis build. A Genesis config that then gets built. And so, for example, you might want to pre-populate you have a voting palette where people can vote with their tokens or whatever, and you might want to already pre-populate it with some voters. And this is one way that you can pre-populate that storage. This is not just useful for testing, this is also for the actual genesis of the actual chain, but this is a good context to introduce the concept. So this Genesis config is a general thing. I would even say, if you only need it for the tests, consider not adding the Genesis, because the Genesis is meant for the production Genesis. If it's only for the tests, I think you can skip the Genesis part and use the next thing that we'll talk about, the builder, and sort of.
So meanwhile, does anyone have any questions?
Yeah, feel free to ask questions.
We can later answer them on Discord if this is not heard by people on the stream.
There is one behind you. What is your name? I would like to know your name.
Iman.
Iman?
Yeah.
Okay.
So my question is related to the builder one. It's just like as if I'm feeding the Genesis. Let me go back to the
previous slide.
Yeah, because I forgot the
this one.
It's slide 11.3.
Yeah, that's this one.
So here I'm feeding the Genesis config with the data I have. So it's not the builder, it's not something kind of like I need to import just like your X, Y, and Z function, and you are implementing on your own logic, and this is how you are feeding the Genesis with the data you need. And whenever you want to update the state, you just kind of call the function. My question here, after clarifying the sport, there is no out of the box for the basic common things I'm just like kind of referring what I used to use in Solidity. For example, mocking the balance where I have like just send the address and it gives me whatever number of tokens or number of ether in the balance account. So there's nothing like this
I think not as part of the library. I think the common pattern right now is still to copy it around. This would be a nice project actually, to be like, oh, we use balances all the time. Let's have a small builder that allows,
it is like Foundry test, like so many things, you just like reuse it and booming, you like have everything you need for testing.
Yeah. So yeah, you're right. This would be good, and I encourage you to make that a project. Yeah, I think we can
Would
probably.
be my assignment.
No, not assignment, but for after the assignment, yeah. I think Cisco can confirm. I think we can probably get a bounty for someone that's willing to implement something like that.
To have helpers for testing?
Yeah, we're talking about the builder pattern, and it would be really nice for common palettes, like the balances palette, that you need to populate all the time, to have these kinds of builder like helpers to initialize it. Maybe they also already exist, and I just don't know about them.
Yeah, it would be a good idea. Like if we don't have it, then it's probably something you can work on. Yeah. Like we have implemented the builder pattern for some common scenarios. In testing, I think everyone creates a custom builder because they just copy and paste the code that is already in some tests.
Yeah.
But some like testing framework would be nice.
So we're still on the audio issue, right?
The audio issue is fixed.
Oh, it's fixed.
Yes.
Great. Amazing. We were build up. Cool. So you've already seen the parameter types. A thing that you might not have seen is that parameter types has a little bit of juiciness, a little bit of extra that you can use, which is a keyword called static, and it's test only. You can basically create a static variable that is settable in the background, and it's very useful for tests because you can change the configuration and check how does my palette react to a changed configuration. And similarly, storage. This you could use in production. I'm not sure it's used in production anywhere in actuality, because I think it brings its own problems with it, but you could in theory. But also for tests, you can just create a custom storage as a parameter type, and then you can set the storage.
Yeah, so that would create a key, like outside of any palette, it would just create a key that I think the key would be my max voters, like the name you put in there, and it will actually put it in storage.
Yeah.
So normally configuration items like are not in storage, they're in like they
in the code.
Disappear after compilation. But this will be in storage, so you can use it in production. If you use it in production, the actual value that you see there, the equals 100, will have been changed, probably. So you have that issue.
Yeah.
You only get that value once, and then once you change the storage value, and it's gone.
Yeah. And the benefit, of course, is you can then use governance or something to change the value, the configuration value. And
yes, so that's a very nice benefit. Like some things, for example, I don't know, inflation rate, which is a hot one right now. You could put in storage so that you can like decide via governance if you want to change it, and then the change is enacted on chain, and you don't need someone to go and change the hard-coded value on the code.
Yeah.
Now we have a palette called palette parameters, which lets you very easily set parameters like create keys and values, and then you can decide on those values via governance if that's something you need.
Yeah, and that would probably be the recommended production actual thing, is to use the palette parameters. But, yeah.
One question here.
Yeah.
Like when we use a storage keyword in the testing, in this case, like the kind of test where you are across different unit tests, you want to keep, it's called, I forgot the name of the testing. It has a name. Let's assume I have like three function to test, and I want to keep track of the value when it's changed. It's not unit testing. It's called sorry. It's not end-to-end. It's kind of like, let's say I want to, this function would test when I am updating your balance, and another function will rely on the output of the other function. So I can use storage keyword in the my test to keep track of the value change, what the change in the value.
No.
So why I should use it in test?
Yeah. The only thing I can think of right now is because it's in storage, you could make use of transactional storage to reset it.
Yeah,
that kind of
but
thing.
in my test, once I finish my test, nothing. Just like,
Yeah. Once the test is over, the storage
so why I'm
externality.
using storage in this case in my test?
I think it's not working. You can maybe get Iman's.
So we actually use it in some tests. And we, for example, we have a lot of, in Polkadot SDK specifically, we have a lot of different chains which act kind of like the same way. Like, for example, we have more than one testnet, like we have Western, Rococo, Paseo, like a bunch of things. So and in different test scenarios, we use like a storage to, for example, an asset that we want to have in some setup. And then when we are starting a test, we just set the key to that. On other tests, we set it to a different thing. So I think actually static is already all you need, because storage actually puts it on the storage. And for tests, basically with static, I think you're fine. But there might be some reasons why you might want storage. What is for sure is static is a good idea to set it on at the start of a test, and then, yeah. I believe. Yeah.
My sense is getting a bit too in depth. Yeah, either ask a question or we move it after the session. I would like to move on.
One thing I wanted to say. So you use static to like be able to change the actual value. And I think storage existed before palette parameters was like a thing. So storage was the way to set, because with, what's the thing? With frame, basically all storage is confined to one palette. And if you want to set a key to some sort of parameter, you would need to use SPIO storage set, just like the low level API. So I think this was created as a higher level API to do that, but now palette parameters is the way. So maybe this is more like a legacy thing.
Yeah. For me, it was more of a like giving it to you for completeness. You have it as a tool in your tool build. Yeah. Cool. So one of the things that you will want to do in your tests, especially when testing hooks, which we'll cover tomorrow, you want to mimic the progression of an empty block. So we can just fake that. So the very straightforward way that you can do it yourself is you just write your own next block function. I think there is now a helper in the testing utils. If you want to know it, I can check and see if I find it. To call the different onFinalize and then set the new block number and then call onInitialize. And then that way you can sort of mock the progression for your particular mock runtime that you're using.
This is also something that would be nice to have, like some sort of crate or something, like a testing framework.
Yeah, and it might already exist. I'm just not familiar right now. Yeah, so the all palettes is a useful one here, right? The construct runtime that we covered in the first half will create the all palettes, so you can use that to progress the blocks. So you can initialize with some values and then build the whole thing and then go to the next block. assert that some condition is true, and then you can go to the next block, and then that way you can test your hooks if you need to. Yeah. Just a note that sort of there was the Cambridge PBA created a pull request to improve some of this. Cool. All right. That means we're through quicker. Okay, that was not what I. There we go. That was faster than I thought we would be. That's amazing. What I would do is I would just have a quick look at some chart.com very tech SDK. You can see this? Yes, you can. Cool. I bookmarked it on my laptop, but because of the tech issues, I can't. That was in the nomination pools. Yes. I wanted to show you a real life example of what this looks like. Yes. Mock. Yeah, thank you. Good point. Is that good? Or more? More. More zoom. Even more? Even more. Okay, all right. Did you forget your glasses? Cool. So these are the nomination pools. This is for the staking, I presume, in Polkadot. So it's a nominated proof of stake. So we have nominations, and then we can have members and max members, and so you see, in production, this is not in production, it's testing, but in real life, in the Frame SDK itself, you can see there this pattern is used, and I thought maybe that would be illustrative to see how it's used in practice. So, we have these like add members, you can set the existential deposit, the minimum bond, these kinds of things. No, I don't want you. Okay. And then the build will create the Genesis config as we've seen in the slides, and use the configuration. And then this is a good example of the other strategy I mentioned, right? If you don't want to introduce a Genesis config just for the purpose of testing, a thing that you can do is you can just say like, oh, I want a pool, a nomination pool created as part of my test setup. And you just do that. You just create the test externalities, and you just execute some code that is common before all of your tests or some subset of your tests. And it's super useful. And I think you will want to make use of it in your assignments for the testing parts of it. And this is another time to repeat this one here. If you want events, right, to set your block number. I think I showed what I wanted to show. Any more questions about testing? Question?
Because we have time, can we go through, I don't know, one test that in particular that you have as interesting test? As I see you have here a lot of links.
Yeah, we can see if we can find where this is used, right? So, tests. Look at the default. See if we can find something where we're not using just the default. Move and execute. Here, there, right? We configure the max members per pool, set them, and then build and execute. So this is The existential deposit change causes reward deficit. And so I think this could be part of the builder. I think I saw this in the builder. So that's sometimes the alternative, right? If you just have something for one test, of course you will just set the storage directly in the test, and then if you have 5 tests and in all of them you set the existential deposit, then you start pulling it into the builder to be able to do it beforehand. We set the balance, we join the pool, and then we have some. This is also a common pattern that I have not covered in slides yet. That I recommend is often you would just, as part of the test, you want to do some repeatable functionality, right? And so here is like deposit rewards. We want to we can jump there. Nice. There. Right. So we check the free balance, and then we add an amount of the reward, and then we set the balance. So this is basically like a mint, right? It's basically minting, right? We mint some tokens into it. Come on. Okay. I'm sorry, I don't know Safari. I'm struggling with this laptop. ED change. Yes. Okay, cool. Yeah, then what just happened? Someone is trying to call. I probably don't want to accept the call. Gigi? There's a call coming? Okay. We go back. Nothing happened. Good. I'm trying to find a pattern I wanted to show that I figured would be in this test. So one thing I want to say about this test is it's too long. I recommend you don't write tests this long. Maybe this is necessary. I don't know this particular test super well, so maybe it's necessary. I recommend tests that get this long, split them up, separate them out. Just general advice. Yeah. So I think this is good in the sense of like, yeah, it uses the builder pattern to set things up, and it has this, deposit rewards function, that kind of pattern, that's good. And then it's a little bit hard to tell, like, okay, I guess this one is one of the things to test. And then I guess this one is one of the things to test. Here, this assert. Yeah. Any more questions that you want to ask about this code or about testing in general? Otherwise, we can also just go 5 minutes early into. Yeah.
Thank you. I was wondering something related with the security audit process. I assume unit test is like the baseline, but for some edge cases, are there any crates focus on fuse testing or for formal verification?
I'm not aware of formal verification. Feel free to anyone correct me if you know any. A thing that I've used in my job, in my development work with this, is property testing. So Rust has property testing frameworks, and you can use these with frame code, and that's a good way of testing. Like property tests, right? You give the range, and then it uses randomly generated inputs based on the configured ranges, and so you can find edge cases. That's one way. Someone raised their hand.
This covers fuse testing as well?
Can you define fuse testing to me? Sorry.
Like inject like random numbers to try, like in stress testing, injecting random numbers to, I don't know.
You mean fuzz testing?
Yeah.
Okay.
Sorry, my pronunciation.
Yeah, no worries. I thought it might be a special acronym. I don't know. Fuzz testing. Yeah. So you can also do fuzz testing. There is fuzz testing used in Polkadot SDK. I'm trying to remember. Was it reusable, Cisco? Do you remember? I know that it's used from time to time. I'm not sure there's like a super easy, repeatable kind of way set up already. You don't have a microphone. Okay.
There are some fuzzing like libraries, and I believe on the Polkadot SDK you can find one, but I've never found them really easy to use. I haven't seen one that is like very easy to use, very well documented, and so on. There might be one out there if you search for it. I can search for it and see if I can pass it on Discord.
My recommendation is property testing because it's very similar to fuzz testing, but you have more control over exactly how the inputs are randomly generated for your stuff. So especially for, like, you don't have to use it for your assignment, but if you were to use it, I would recommend property testing rather than fuzz testing. Fuzz testing is, to me, more of a black box, like I have the whole runtime or something, and before I release it to production, before I start my Genesis, I do some fuzz testing on it. It's definitely recommended, and I know auditing firms do it, and I encourage you to do it. It's not part of sort of the daily workflow that I've used. Yeah, but yeah, property-based testing definitely recommended. I know it from my time working at Hydration. So you could check out their repo; it should still be there. They use property-based testing. Maybe Cisco, could you find or I can also after the lecture, I can find the link for how they use it. Or can I? Let me see. Nope. No, I don't want to sign up. I just want to search. Can't search. Nope.
It might still be HydraDX, maybe.
Yeah, no, hydration node. Yeah. And then can't search because I'm not logged in, right? GitHub is terrible when you're not logged in. Palettes. I think yeah, prop test regressions. There we go. Tests. Invariance, I think. Yeah, I think this is, yeah, cool. So this is using prop test. And there you see that, normally a test doesn't have any parameters that you pass in. And this one does, because prop test is a macro, and it generates these randomly. So valid asset IDs, for example, is something that's generated here, there, right? So it says any asset ID, so any means it takes the whole range of the type and generates a value for it. And then there's a prop filter, like, oh, the ID shouldn't be the same. And so it will randomly generate this, similar to fuzz testing. A little bit like, things like prop filter, of course, make it not quite like fuzz testing. But yeah, but very similar. And so I'm showing this code because I know it because I wrote it, and not necessarily this line, but I wrote invariant tests for this Oracle thing. Yeah, and so that's why I just happened to know that it's possible and wanted to show it. Very useful for math. Very useful for things that can vary a lot.
I think we're on the. Is 12:30 the finished? Okay, we're finished then.
Then we're finished. Okay, then thank you very much.